And welcome back to AI Diatribe. My name is Jason Lowe. I am your host, and I am joined by two gentlemen today, the first of which is my co-host, Mr. Matt Konwiser from IBM, that you may have seen before if you've listened or watched previous episodes. And today we are joined by actually a personal friend of mine who just so happens to be doing some really fun and exciting things in the AI space. My friend's name is Jon Rolls, and he is the CEO of Tassient, which is well, you know what, John, I think to do it justice, let me turn it to you to explain what it is that you're doing with Tassient, particularly as it relates to AI in the tech support space. But I can turn that over to you, and you can give us a little shindig on your journey a little bit, and make sure that you include what your favorite color is, John.
Am I in elf? Is that what we're doing here?
Yes.
Buddy the elf, what's your favorite color? Hi, everybody. And thank you so much for hosting me and giving me a chance to talk about Tassient, which is our new company that we're launching. Everyone says, what does it mean? It was a domain name available quite inexpensively, but sentient tasks, something in that general area. We wanted to do, we both, me and my co-founder have both been in IT endpoint management space, whatever you call that, for like 30 years. And the category seems to be called remote management and monitoring these days. Basically, I'm an IT department, or I'm a service provider. I'm responsible for helping maintain a fleet of devices, usually PCs, laptops, Macs, that kind of thing, servers. Being able to do that from the cloud remotely, anytime, instantly, getting alerts on what's going on, reporting, discovery, troubleshooting, all of that kind of stuff. So we built a platform. This is our second time doing one of these, and we're just starting to launch it now, work with some early adopters and some customers. It's going really well, but the thing we wanted to do from the start is build AI into it. So that's why I listened to a few of your episodes, and honestly, you're a lot of really deep AI experts on there. I think my perspective's a little different. I come in as someone who uses it every day, is integrating it with the things I'm doing. The point of it is, if I'm a service provider or I'm running a small business, the last thing I want to do is spend my time finding a fantastic sysadmin to manage all my stuff, servers, desktops, whatever. They're expensive, take forever to train, you can't retain them. All the knowledge in their head is already out there on the internet. So why not join these two things together? Why not embed AI into an RMM tool so you can directly query and fix and resolve and investigate problems live with the help of AI? So it's like having the world's most knowledgeable tech support assistant right next to you while you're trying to fix and investigate a problem. So that's what we're building. We had the advantage of starting from scratch. Unlike many other people in this space who are trying to bolt AI onto it, we embedded it from the start. Yeah, it's been interesting. You create a framework. You say, hey, Mr. AI model, you have the following tools available. You can do this to the device. You can extract this information. The user is reporting this problem. Go figure out what's happening. And it comes up with things we never would have thought of. That, hey, I'm going to write a script and go run it on the endpoint. I'm going to go and pull this information. We've given it access to like the last 7 days of activity, so it can go diagnose what's happening. The user's saying sometimes they can't connect to whatever, so it will go and find their Wi-Fi signal history or whatever. So it's been fun. It's interesting bringing this new world into an industry we already know very well, and we're learning every day. And the trick in it has been actually how you tell the model what the tools are at its disposal and how to use them. You say, right, here's a tool, for example, you can go and you can read the contents of a file and it will say, great. But you don't want to read all the file because it could be enormous. It'll blow out all your tokens. It'll lose its context window, that whole thing. So you say, I recommend you only read 50 lines at a time. So it will do that. Well, also it turns out that LLMs are terrible at reading 50 lines because they tokenize everything and they have no idea what line 30 is. So we had to find a way of sending it in such a payload in such a way that it could easily find line 30. And then it could do more intelligent things and it could fix the file for you without screwing it up. So it just, lots of iteration like that. It's sort of training a model through prompt engineering. So that's the kind of stuff I'm involved with right now.
So here's an interesting one. You said you didn't necessarily want to go too deep into the bowels of AI design and model building. So I was thinking about two different routes you could take. I'm gonna do a choose your own adventure here. So I'll ask you two different questions, and you can pick which one you want to answer.
Okay.
So the first one is, how do you feel about open weight models with very low temperature when dealing with trying to troubleshoot and diagnose all of these different issues through vast amounts of data, lots of different files, and lots of different system types. The other one is, do you feel like a company like yours that is in the endpoint and overall systems management business can survive if they do not adopt AI?
I'm going to go option 2 to start with, and we'll probably come back to option 1. They're really good questions. Probably no. And the reality is that it's like any revolution, whether it's agricultural, industrial, you're changing the way people do business. And this is an area that's absolutely ripe for that kind of disruption. So yeah, you either get with the program and learn how to use the new tools at your disposal, or you're going to go out of business very quickly and become left by the wayside. And as I said, we had the advantage of building it in from the start. When we architected this thing, we didn't start with, hey, we've got a 20-year-old product. It's got a massive database full of stuff in the cloud. Let's throw AI at it and see if it can figure out anything useful, which some of our competitors are doing. We didn't take the view of, here's a screenshot. I'm sure you can figure out what's wrong from there. We actually, we can do those things, but we more importantly just built it in so it has a live real-time connection. So that was interesting. If you only rely on hiring humans with their limited knowledge and their limited expertise and wait while they research the internet, you're going to get left behind. Now, that said, I still believe you need humans in the loop, of course, because it's like, I keep saying, it's like having the most knowledgeable infant sitting next to you. Like, in an instant, it will tell you anything there is to know that's been scoured from anywhere on the internet. I mean, the best training data for AI models, right, is your Stack Overflows, your server fault articles, all those things. So it's already got all that baked away in there. It will produce, the kind of articles and the know-how from that in a heartbeat. It just doesn't know how to apply it. So that's where we came in. Partly, it's got to be the human saying, here's a problem I'm trying to fix. And partly it's what we've built into the product, which is, if you come up with something like this, here is the tools at your disposal to go look at it. We recommend you use it this way. We recommend you start by using this one first, which won't interrupt the user. And then if you have to interrupt them, there'll be a human in the loop to approve it. It's that kind of closed loop we had to come up with to make it work.
Well, let me ask an interesting question here, because, I mean, this isn't your first rodeo. I mean, obviously you did things with Control Up, and I want to pronounce this right. Tell me if I'm getting it right. Avicii?
Very good. You're about the only person who ever got that right first time.
Yes.
Yes.
I figured.
I'll tell you the history on that name in a second, because it's quite funny. But yeah.
Okay. But it's kind of interesting. I mean, looking back at when you're launching Avicii, and I mean, I realize that you were instrumental in Control Up, but not the instrumental role that you played in Avicii. Looking back, are you doing things now with Tassient that if AI was available, you would have done with Avicii back then? Yeah. Do you feel like, were there lessons learned that you did with Avicii that not only formed the way that you're doing things now with Tassient, but now you even make that even more elaborate by incorporating AI? What are some of those lessons learned that you had from Avicii that you're still able to incorporate now in Tassient, coupled with all of these AI aspects and influences?
I'll pick on a couple of the. So it was interesting. We built it as, again, a real-time troubleshooting tool. But when Control Up showed interest and ultimately bought the company, they were much more in the monitoring and historical data kind of market, much more analysis of a user population over a longer period of time. And so we pivoted more towards data gathering and storage and querying. And at one point, I used to joke that if this whole career falls apart, I'm going to go into Elasticsearch query writing for a living, because we put terabytes of data into Elasticsearch, which is a phenomenal piece of technology. And I literally had to give classes on how to write queries to get it all out again, because if you go from a SQL background, like most people do, right, it's the reverse. They just like, I want to inner join this, Nope, there are no inner joins this is a row-based database. As it turns out, that career also would have bombed because AI is incredibly good at writing Elastic queries. So, never mind. But that's what we did the first time. And what we saw was actually our customers probably spent 5% of their time querying the massive, expensive database with all the complex stuff, and 95% of the time in the real-time troubleshooting tools. So when we came to Tassient, we're like, let's just double down on those, because there's still a market and a demand for having a giant cloud database full of historical data. And that's fine. There's companies that will do that. I just don't see us going there anytime soon. So that was alone. But I did want to pick up on the name. Avasy was kind of a fun name because, again, it began with an A. The domain name was inexpensive, easy to remember, but it didn't really mean anything at the time. Actually, I didn't pick it. My co-founder did. And then we had to do some revisionist history because everyone said, well, what does it mean? The other good thing is it's not offensive in any language. Having been at multiple software companies, that's your number one problem, is not picking a company name or a software name, which happens to be, like I worked at, years ago at Insignia. We had a product called Intrigue. It was like NT as in Windows NT, but with intriguing. I was like, oh, that's a pretty good name. Turns out in German, it means like morbid. It means like deathly, morbid, intriguer. It never sold very well in German. So again, we had to check that. Turns out in French, Avasy is very close to avancé, which means like progressed or advanced, or so I was like, oh, actually we'll take that. And then for English listeners, we ended up with the explanation that it's like, have a look, but did you have a C? It's like, can I borrow something? Lend it me. It's like, have a look, have a see. Anyway, the name obviously got buried as soon as it got bought by ControlUp, but there's some. We had to reinvent all this afterwards.
I have never done that. I probably should, especially with Aptivon. I should probably go and find out if that means something bad somewhere else.
Yeah. So for anybody watching, in case you're just listening, I'll give you the visual here. You might notice that Jon has a slightly different setup. Right before I asked this question, he had a mic in front of him, and now he's got a maybe circa 1996 Ericsson Bluetooth headset on, I think. I had one, by the way, in 1996 in a commemorative tin, and I loved it. So you might notice there's a slight audio difference. But I assure you, he is still very much him. We did not swap him out for a deep fake. And
you could have done better, frankly. If you're going to deep fake, let's get Harrison Ford in here or something.
So here's the question I had, because we were really talking about a lot of different things in the evolution of business. NVIDIA this week made a statement, their developers, that it was more expensive to hire AI than it was to hire humans. And you were just talking about the need for keeping humans and humans in the loop. And I just did a quick search just to make sure I was fact-checked correctly, but the NVIDIA H100s, an individual smaller version is about $30,000. The larger version is about 40 to 50, and the bank of 8, which is what you'd find in a traditional server rack, is $200,000 to $400,000. Now, that is higher than the average loaded headcount of a low to mid-tier DevOps person that you would hire. And that's, by the way, just to run probably a mid-size enterprise class model, nothing like what you'd see as a frontier model. Now, your whole business is built to some degree on outsourcing, and it's built around an AI agent. So I'm curious to know, where do you see the cost benefit of human versus AI, and what do you think the business model is going to look like? Do you agree with NVIDIA that you can't just wholesale replace humans because it's just going to be way more expensive? And how do you kind of walk that middle line?
So a couple of things. Actually, I'm going to call back to something that came out from another podcast you did a couple of weeks ago, that rack of very expensive H100s or whatever, I bet 99.9% of the compute in that is used for training rather than for inference. Compute is a massively expensive iterative task that, even on Elon Musk's Colossus 2 million GPUs, it takes weeks and 3 gas turbine generators to generate a 1 trillion parameter model.
And a lawsuit from the citizens of Tennessee. Don't forget about that. That's all part of it.
Right. Whereas an inference model I can run on my Mac Mini M4 here, not bad. So I do wonder if we need all this compute power I feel like you're paying these hyperscalers and the people who host these things you're paying their training bill rather than their inference bill. So if I'm using, Copilot here, use it all day, every day, as a GitHub Copilot or plugged into GPT, whatever, I feel that what I'm paying for is not actually the compute power of running that, because I know that's pretty small. What I'm paying for is then to support the data center that builds the model in the first place and is constantly training. Maybe completely wrong on the math on that one. It just seems wrong. But also, to your point, the NVIDIA guy has to say that because he's trying to support his $4 trillion valuation. Unless AI costs that much money to support his share, this is the whole thing. How can Anthropic be worth $800 billion unless it is such a revolution that replaces the loaded cost of an employee or many, many employees? Otherwise, there's a huge price crash coming.
But I have a question then. So
yeah,
Google just recently released, Ironwood is a TPU that Google created specifically for inference.
Right.
So if inference is such a small fraction of the compute that's being done, then why would they go to the trouble of creating something that's inference efficient? Is it just for the time of response? Is it because the compute load needs to be reduced on the inference side to make it 99.5% on the training side versus 99%? What are your thoughts there?
I think it's because it's not just doing one user at a time or one agent at a time. It's having to support hundreds of billions of transactions going through it. Also, from what I understand, like the Tesla AI5 chip, they've got a training model and an inference model. They've actually taped out two separate silicons. So the algorithms and the way you optimize it is a little different. But they're going to put an AI5 chip in every robot. They're going to put an AI5 chip in every car. Doesn't need a huge amount of power or compute, and that will run rings around anything we're using for inference today. So I still think a lot of it is the sheer cost of training. GPT-3 costs what, 100 million in power to train? Whereas I can probably run a model not much smaller than that on my Mac 4, my M4 Mini. So yeah. But look, I'd love to know I'm completely wrong on this one. As I say, I'm an enthusiastic amateur, but
no, you raise a really
based
good
on what
point.
I see, yeah.
If you look at it this way, we're in an AI arms race. The people that are getting ahead in the race are the ones that can actually create these new models that have greater capability. And so 3 weeks worth of training versus 6 weeks worth of training is a pretty significant. So they need this processing power to frickin' get it out there as quick as possible compared to their competitors. So it's more of a competitive differentiator than probably anything. I don't know. What do you think, Matt?
Yeah, so the way I'm thinking about what's happened with the trends, especially if you look at when GPT-2 came out to where we are today. When GPT-2 came out, there was no Hugging Face. There was no repository of fully trained LLMs that had access to all the weights and parameters and all the training data that anybody could download and use on their local machine, and now we do. But we have that because of GPT-2, right? The reason why the Android market exists is because of iPhone. Android existed before iPhone, but nobody wanted it. When iPhone launched, everybody else demanded smartphones and touchscreens and everything else. So I think what started to happen was you've bifurcated the pattern where now most people can survive on a glider and they've got enough lift and enough speed and enough altitude to just keep going for quite some time. But you still have the frontier model makers building JADOs and boosters to keep going up and up and up, even though most people don't need it.
Right.
So at some point, it'll catch back up again. But here's what I'm thinking, and this is kind of where my follow-on question is. I also have a Mac Mini M4 that I'm running local models on, that I built my own applications for, that I use every single day. I see all these conversations now about tokenomics and token maxing and using tokens as a measure of employee effectiveness or employee impact. And I guess I take it for granted, but I don't care. I'll break the barrier for this one. I don't give a shit. And the reason why I don't is because it's my Mac Mini. Like, I monitor the power it draws off of the UPS it's plugged into, but I'm not paying monthly bills. I downloaded the model for free off of Hugging Face. I wrote some Python to sit around it, and it does exactly what I needed to do without me having to use subscription services to do it. So I don't.
Exactly.
The whole economics of tokens is out the window for me, and it's a non-issue. So my question to you again, somebody in a business built on AI agents, where do you see the value between having to use a frontier type model that is using those hundreds of millions of dollars of energy to train and these massive data centers to run, versus obviously you're not running your whole business on an M4 Mac Mini, and if you are, you wouldn't tell us, but where do you see the split point in the value and the need between having to go with the jet assisted rocket that's going into the stratosphere versus the glider that's coasting along just fine?
Right. As you say, it comes down to economics. I mean, right now we have the advantage of being able to use the latest model, the greatest trained thing. I mean, we just switched to 5.4 and I see 5.5's just arrived. And it was amazing the difference it made in troubleshooting problems, the extra level of intelligence that was there. And for the time being, it's still very economical to use it. We get the benefit of huge numbers of cached tokens, which cost a tenth or less of non-cache tokens. So as long as that's still the case, now at some point, they've got to justify their valuation, their share price. I think the economics will change, the price will go up. And at that point, you look, do you then switch to running your models locally or in some other hosted fashion?
Well,
So
now
for your
context
business,
of the tax that's actually being done, right? I mean, this is why Claude still offers the lesser models, because you might have something that doesn't need all the horsepower. It doesn't need the firepower. And so having access to the frontier model, great. Let's make sure that we're doing some sort of a middle processing step that's figuring out what the right model is to use for this particular prompt. This could be low horsepower. That's why the whole auto feature on GPT between the different models is now standard. You can't go and select the right model. You have to deal with it telling you which model it's actually going to use now.
Yep. I think is an analogy I thought of. It's not perfect. It's a lot like pharmaceuticals industry. You have these companies out there spending billions researching and doing trials and investigating drugs and employing all these super expensive PhD people and massive labs and all that stuff to generate a drug. And when it comes out, it's insanely expensive. You would only pay for it if you had a life-threatening medical condition because, demand-based pricing. I mean, it's worth it. Fast forward 10 years later, it's become generic. Now it can just be cranked out. I mean, maybe it's not quite as perfect, but it's basically the same cure. It's the same technology that's moved on. And anyone can get their hands on it. And meanwhile, as you say, researchers are still working on the next one. And I do wonder if we end up with AI models falling into something like that, whereas the cutting edge one 5 years ago is the absolute generic off-the-shelf, cost nothing. You can run it locally now, except it's moving faster than 5 years. But I'm sure you get my point.
Well, Gemma 4 is the equivalent of, Gemini 2 something now, Anyway. So it's actually kind of interesting because with you venturing off into a new business venture, we talked a little bit about the lessons learned and what you have done a little bit different, but I am curious. I would be curious to hear in this new way of incorporating AI in the way that you're doing business. And obviously the agentic side of things is paramount, but what would be the one pleasant surprise that you have experienced now that you're using AI differently than you have before? And what has been the most, I don't want to say depressing or negative surprise that you have had? I mean, what's been a positive surprise and what's been a negative surprise with this new way of setting up your business?
So this is a good question. I was thinking about this last night. What are we going to talk about? I've actually had a mixed experience with AI. Everyone else is running around saying it's the greatest thing ever, it's changed the world. There are some things it's not good at. I'll tell you my experience. The first one has been, the positive was how much more a handful of developers can do now. In the hands of a good, seasoned developer, it's an unbelievable accelerator. It will save you so much time, you'll find problems faster, but you have to know what the result should be. I think this is where Anthropic's struggling right now because they have Claude writing Claude and the quality's gone to doo-doo recently. So this is what I've seen with it. Where you have a good developer, it's a time saver for them, but they have to check and in some cases clean up what it did. It'll still get you there 10 times faster. And it's very good at troubleshooting when something goes wrong or it blows up, really good at analyzing error logs, anything that, again, where there's lots of training material. So that's been great. That's been a good surprise. And secondly, how good it was at being given a handful of tools and some instructions and improvising solutions to really hard problems. I mean, we're still seeing that improve as the newer models come along.
Do you have any examples of that, just out of curiosity?
Yeah, I can probably give you some obscure ones. I had a networking problem, actually, just locally in our build lab. And just could not struggle it. This went on for like 30 minutes, and the troubleshooting session, and I'd be like, great, let's go to the one end of the machine at one end of the connection. Here's all the out-of-the-box tools we provided for it. And it would say, well, actually, I want to dive deeper on this. And it was writing scripts and performing things and unlocking networking handles. I didn't know this stuff existed. Somewhere in the internet, it's been trained on all this. And it was able to resolve problem temporarily, but then it said, no, problem's not at this end. You go to the other end, and we're cross-platform. The other end was a Mac. So fire up the Mac. Now let's run the same troubleshooting steps at this end. And I mean, it's one of like 20, 30 minutes of it trying and fixing and resolving problems and unlocking things, and finally came to a conclusion and just said, what you're doing is actually probably not going to work. You need to work around it this way by doing a copy step first and then running it. I actually put a short version on YouTube. I can edit it down to like 2 minutes for anybody who's interested. But the level, the size of troubleshoot, the kind of the scripts it was building and the complexity that it was dealing with to get to a solution was really impressive. And I mean, it went far beyond what I don't know. I know some people who'll be like, oh yeah, I knew all that stuff. I could absolutely have fixed that problem in 2 minutes. But okay, there's probably like 10 network engineers on Earth who would know the level of stuff that was doing it and the tools that are available. But it did stuff I'd never seen before. And that was really impressive. So that's the big positive. It brings knowledge that would go far beyond the average human troubleshooter, and it applies it in real time. Yeah.
So here's my question then, because it happened this past week and it happened a while ago as well. If your developers are using AI to do that type of troubleshooting, whether it's network or data design or applications, and the model deletes a whole bunch of information, just wipes it out, whose fault is it?
In the case of if it's code, it's the developer's fault for not taking regular commits, because you can always just rewind. And but yeah, I mean, actually, that happened just seconds before I jumped on this podcast. I was working on a piece of code and I asked it to help clean up, and I couldn't figure out a particular structure. I was moving from C to C#, and it did a nice job of commit, and it deleted something else in the process. I was like, why have you done that? And fortunately, there's undo buttons and commits you can revert and things. But if it's more destructive, I get your point. If it is literally gone to a database and blown the records away and you have no backup, you either got to use a human in the loop system and hope that the human pays attention, or you're going to have regular backups. But these mistakes happen with humans in the loop all day long.
They do.
Yeah.
But my question is, do you, in the two examples that have been very public, like I said, one this week and one maybe about 6 months ago or less, do you, in both examples, the media was very publicly blaming the model? It was the AI went ahead and deleted all this stuff, even though it was told not to do that. And do you subscribe to the media's interpretation, or do you think that the responsibility is still on the shoulders of the DevOps people?
So I'm going to give another one that caught my attention as, again, a media spin. I mean, they love this idea that we're all heading into, the Terminator series of movies here, or the Matrix or something. And people will click on that and read those stories far more than they will than, there was a minor upset, someone misused AI. What they want to hear is the AI is taking over. People will click on that. So one was the Mythos one, when the guy went for a lunch break and got an email on his phone that I've broken out of the firewall, Now, the backstory is, they were intentionally researching security holes. The model was told, go and find the holes in this and send me an email when it's done. So it did exactly what it was told to do. It just did it in an unexpected way because they thought the firewall was unbreakable. It turns out it wasn't. But again, the story as it turned up in the press, in the media, was, oh my God, we're all about to be hacked. Skynet's coming. We were going to click on that and read that, right? And get advertised. I mean, they can sell advertising space on those stories for a lot more than they can. GPT 5.5 got more parameters.
Yeah, well, Matt's kind of working in the direction of a conversation we had on a previous episode also, where it was just the two of us having a fun conversation. And Matt, if you don't mind, I will go ahead and I will talk about this. He asked me a very pointed question. He said, in the scenario of possible damage being done, is AI the gun, the bullet, or the shooter? So I'm curious to hear what your answer is in comparison to the one that I gave a few episodes.
Did I get as far as your answer? I definitely listened to the discussion. Is AI the gun or the shooter? No, AI is the gun. As long as it's got a power cord and you can pull it out. Now, of course, in the movies, we know that actually it'll stop you from doing that because it will shoot electric lightning stuff at you as you get too close to the power outlet. The other thing that actually I was listening to your podcast as I was on a walk, and I was almost yelling out loud. People must have thought I was crazy, but well, maybe they do. But the other one is, okay, so if AI does replace all this stuff, who's going to buy the output? At the end of the day, the market is humans. There are people saying that AI to AI commerce will take. I mean, where's the demand for that? Who's interested in that? Ultimately, we're the people who want the things that AI does. We're the ones who want to pay for it. We're the ones who need it. If there's no demand for it, they'll stop making it.
Well, so now this kind of goes to another little bit of a dovetail of a conversation we can have, and this is something that I've asked.
Sorry, did I pick the right answer there? I feel like I validated you.
I said gun.
Yeah.
And so we are of like mind there. Matt may not necessarily 100% agree, but yeah, that's what I said. I don't know.
I'm a bit more neutral on the topic. I think that it could be the bullet or the gun, but I don't think it's ever the human that's behind the trigger.
I mean, you could make it. I mean, if an AI robot with a loaded weapon, is that the gun? I mean, it is, right? But it's only because someone told it to trained it to go do that.
Yeah, but then it's got to be deterministic, not probabilistic. So,
Yeah.
Have we hit that level yet? Who knows? That's a whole other conversation.
That is a big conversation.
If we could revert back to the socioeconomic, yeah, Matt's going like, cut.
Don't go there.
Let's not talk about that.
Redirect.
Let's go back to the socioeconomic impact. Okay.
When do we go to commercial breaks, by the way? Because I feel that would be a moment for Matt to go, no, we don't do that.
And we'll be right back after this commercial break.
Yeah.
We can all switch our microphones out.
Yeah.
We can yell at each other for 5 minutes and then come back and pretend nothing happened. Yeah.
You know what? I'm just going to leave all this in. I'm not going to edit any of it out, including me sitting here talking about not editing it out. I'm going to leave this in because this is too fun. All right.
It's natural.
So let's go back. So the World Economic Forum, they are saying that AI is going to be responsible for a net gain of jobs in the quantity of 78 million by the end of this decade. Now, obviously, there are jobs being destroyed. There are jobs being created. They are not the same jobs. They don't pay the same wages either. Okay. So you're a founder that's building with AI. This is very, very important to you. You are trying to multiply what one person can do in a day. You've said that specifically with the AI coding tools and things that you're doing to squeeze every ounce of productivity out of the developers, including yourself, that are doing these different things. So now the question is, are you part of the solution or are you part of the problem, Jon?
Is there a problem?
The
lesson from history is, you look at the agricultural revolution. I mean, you guys have done your family tree research, but my family, you go back enough generations, everyone's a peasant on the land. I've been back to the villages they lived in the UK from there. And 98% of the population of the UK worked on the land. That's true of most societies 200 years ago. And now you still need farmers. You still need expertise. There are still fantastic farming colleges. There's new technology. You just need 2% of the employees that you needed then. So where did they all go? Now, there was some industrial strife. I mean, there was, peasant revolts and things like that. The windmill, look at the windmill. I mean, that changed a lot of jobs for people out of work. But it also created new fields that previously they could drain the land. We've been through this before. And everyone who used to work on the land, they ended up working in a mill, or at least they had a brick house to live in now rather than a mud hut. And then the mills become automated. Well, where do they go next?
Yeah, but so you're talking about the principles of economic creative destruction, which, obviously historically show as being pertinent. We have never had such compressed disruption, though. This is unprecedented because I'm not, and my theory, or, I guess my thesis in a certain sense is this advance is happening so fast that humanity itself cannot keep pace with this change. I mean, when the automobile came out, it took 20 years to transition all of these horse tenders and stablemen to get them to become auto mechanics. It took a long time. We don't have that kind of time now. I mean, it's the disruption. There's going to be a lag due to humans not being able to reskill and relearn and change their paradigm. We're not only fighting education levels, we're not only fighting different changes in technology and the way that we're doing business, we're fighting the fact that humans can only learn so fast, A, and B, a lot of them don't like change. So we've got a double whammy here that's going to cause this upheaval to, in my opinion, be a lot bigger than anyone's even really thinking about when they're giving the economic creative destruction argument. I'm just not sure that the economic creative destruction argument can hold water in this particular scenario, but that's just me. Do you agree or disagree?
So the question is this a faster rate of change we've seen before in any industrial wave?
Yeah, more or less. Do we have reason to have faith that humanity will be able to keep up with this pace?
Well, I will tell you this, we're way more adaptable in real time than AI is. So I've got a couple of friends who are university professors, teachers, one of whom I reconnected with after many years. He was doing language model research 25, 30 years ago. He's a professor in computational linguistics. And he would be talking about, we're tokenizing language, we're looking for common themes and patterns between different languages so we can break it down into a computer model. That's very clever, but that'll never be useful for anything. Here we are. It's all anyone does all day now. They did a bunch of School of Communications, actually at USC. They did a bunch of tests, and they went back to some old management models from the 60s, 50s, 60s, where you put a small team together and you give them a task, and you watch how quickly humans adapt to the task. So in real time, we will actually make up a lingua franca between us to try and describe the thing we're doing so that you can break up the task and everyone adapts to it very quickly. We're very good at that. This is where human intelligence is very different to artificial intelligence. We do not need many billions of watts of training to learn a relatively new, simple thing. We improvise on the fly, and we adjust very quickly, and we self-train. And what they were doing was they were mixing humans with AI models and seeing how the team worked and could it solve the problem faster. And actually, it solved it slower because you lose its ability to adapt to the problem in real time, unless it's already a well-known, well-established problem, in which case you don't need the people at all. So some things will be replaced, some things will be simplified. I wouldn't be a contract lawyer right now.
So we're in a very interesting time with occupations and the use of AI and mixing humans and AI, right? So
yeah,
I'm going to give you some interesting facts. And 2026 is a very interesting year for technology because in 1976, the Apple II was introduced. In 1986, the 386 came out. In 1996, Google developed their core algorithms for search, which gave birth to internet searching and everything else that we've now spammed. In 2006, Amazon developed EC2 and AWS. So every 10 years or so.
What happened in 2016? I was leading up. I thought.
Well, I can give you a 2016 as well. It just wasn't as relevant because the point that I was making is if you look at the leaps from 76 to 86, right? To go from the Apple II to the 386 in 10 years was, lightning speed at the time.
Yeah.
Looking back on it, you'd think that should have been done in 12 months. Every leap has gotten shorter and shorter and shorter. And if you do a little bit of an analysis of overall impact, if you look at the first 10 years as your standard unit of measure, we're now looking at achieving that type of a leap in about 9 months. That's how much we've shrunken that window. So I have two thoughts on this. The first is, and the second one was based on the last thing you said. So I'm going to ask this and I'm going to ask the second one all kind of together because it's one of Jason's favorite words too that I'm going to bring up. So with this rapid acceleration of technology creation and capability, coupled with the ability to run it all locally, and you don't need massive data centers to do it, like we talked about earlier. How is that changing everything, even from an endpoint management perspective, right? Because if you look at the cycle, it started with mainframes, and then it went to the edge because personal computing became more powerful. Then it went to the cloud, and then it went back down to the edge now. So, we're doing one of these kind of things, and it's putting pressure on local networks. It's putting pressure on local systems. It is putting pressure on data providers, not application providers, but data providers. How do you see all of that trending, folding into what you just discussed on the mixture of human and machine and even your business model?
I feel like I have a really good answer to that, but I don't know. You're right. I've definitely lived through, even in my working career, lived through these swings. The Apple II, by the way, first computer I ever touched, one of my best friends at school had one. And I just thought the thing was unbelievable, but we had less money. So I got the computer kit you soldered together on the kitchen table, which frankly was the best possible education because, I knew every component of that thing worked. Everything about it because we made it, me and my dad. So where'd it go? So yeah, the pendulum swings back and forth, right? I mean, I worked at Citrix for 4 years, and I worked in that whole virtual desktop world I still do sometimes. And again, we watched compute power go from be re-centralized for a whole bunch of reasons: some performance, some security, some choice of access device, and then come back to the endpoint again as internet bandwidth increased and security controls and the operating systems got better. AI comes along, everything's back in the cloud again. Now we're running these things locally. So yeah, I guess it continues to swing back and forth. You could go back further, look at the mainframe. I mean, the mainframes were what you needed to do computing before the PCs came along. So do we go back? I know we need another technology wave. I did think the point you made about the 10-year cycles, a lot of those were manufacturing delays. We couldn't get from an Apple II to a 386 much faster because you needed a computer to design the 386 chip on, and that to improve to a point where you could actually do that. And we had to improve manufacturing processes. So it wasn't, humans didn't evolve and become more intelligent in 10 years. It was simply you couldn't build the stuff until you'd built the intervening steps that would take you there, and the discovery is in chip manufacturer.
But in your example earlier, you talked about how Claude was now being used to write Claude, and it's gone to, I think your words were doo-doo.
Yes, well, I was trying to be kind. I mean, but have you? I mean, a lot of people have stopped using Claude recently because it's generating more and more garbage, and it's so overwhelmed now that it's really slow. I had to stop using it because it was just too slow.
I'm just thinking because you were talking about the reason why we didn't have the 386 faster was because we needed computers to design the chips, and I'm thinking, aren't we there now where in order to advance AI further, we need AI's help to do it? But
right.
in your experience, doing that is resulting in lesser quality and potentially slower innovation than what we saw with the 386, which is higher quality and faster innovation. So are we seeing
over a longer time period? I mean, yeah, I think that's the difference. The time window is definitely compressed.
Well, we have Moore's Law, guys. I mean, come on. This is we all know about this. Moore's Law has been in effect for so long, and it's evidentiary every freaking day. This is what makes 10 years worth of advancement fit into 9 months. And when it comes to chip design, guys, I'm sorry, but Google's TPUs, there's an upward trajectory on the efficiency increase over what humans have been able to do. AI is making its own TPU chips. And so this is not, for something that is that specialized and designated, it's like the efficiency gain was like 4% in 2023 over what the human design was. And then it was 6%, and then it was 10%. And last year, I think it was 14% or something like that. It's just getting crazy. These things that are specialized are doing the right job. It's just a lot of this comes down to the very thing that you're doing to make sure that your product is very successful at Tassient, which is context engineering. Let's make sure that we're doing it within the realm of what the model can optimally do and not screw up, and give it as much context and information that it needs to be able to do its job. How much of these issues are due to the fact that we're just not using the models in the best way? How much of it is because we're not using it efficiently, or we're not setting it up for success, that we're only setting it up for failure? And I have to wonder if maybe Claude is, I mean, you mentioned Claude spitting out garbage lately. Well, I've noticed Gemini spitting out a ton of garbage for a little bit longer than that. And ChatGPT was being entirely too sycophantic and spitting out some decent garbage before that. So now we are at a place where we're just waiting for the next really good model to jump, because all of these are becoming entirely too not as great as we want them to be right now.
And by the way, sycophantic was the word that I said you love to use. I didn't use it yet, but that was the one. I know you do.
That word.
Yeah. Being a fan of the word sycophantic, but it might even make you sycophantic, ironically. But there we go. Yeah.
Maybe. And you know what? I think you're right. Way to go. That was fantastic.
That is the definition of irony.
You're so smart.
I see what you did there. I see what you did there. Very nicely done. I appreciate that. That was excellent work.
Sycophantic circle. That's what we're dealing with right now.
And there's also an argument that all of these models are converging on the same level of intelligence. So I have some experience of this recently, whereas once upon a time, when we started this thing out and I first was coding, I used Grok quite a lot. Grok may not have been quite as knowledgeable, but it was a fantastic troubleshooting guide. You'd say, I'm still struggling with this issue, copy and paste a bunch of stuff into it. And it would often not give you the answer, but it would help you find it. I found it was really better. And then other ones came along and seemed to be more knowledgeable. And so I abandoned Grok and went to something else for a while, to Claude for a bit, and then bounced around with GPT. Ultimately, now they're all pretty good when it comes to asking coding questions. And there is a theory that they're all converging on a maximal level of mimicking the sum total of human intelligence. And at some point, you're going to ask one model to give you the same answer more or less as every other. So rather than this being an exponential curve where these things just get smarter and smarter and disappear into the sunset and humans are left behind, they may actually just tap out at, okay, you're now smart as the smartest human and you have all the knowledge. What are you going to do now? Is it any different to the AI art thing we're seeing? I mean, you can make me a painting that looks like Monet or anybody, but now go and invent something completely different. It's a mimic. Ultimately, it's trained on training material, and it can only learn from what already exists.
So John, with that, let me just ask you this kind of final thought. If you were to look into the future a little bit, you're talking about models all converging to the same intelligence, humans and models working together, shorter and shorter time frames of innovation. What's your prediction for 2030? What's the operating model of the typical business and the typical software owner? What are we at? Is it one human on the loop and just a whole bunch of AI agents running around on local machines? Is it frontier models running everything? Or are we just all going to be ruled by a machine overlord? Where do you think this is headed?
Yeah, it's hard to say only 4 years into the future, right, where this goes, because economics will dictate this. I mean, as I mentioned earlier, I really think there's a crunch point coming where the cost of developing these models, I mean, with Grok, they're forecasting a 10 trillion parameter model. That's what they're building the Colossus 2 thing to train. The cost of building that, someone's got to pay for it, because we're all just downloading models and running them locally. The economics just fell apart on it. So that will have to change. And if it changes to the point where it's no longer viable to build and run these data centers, they'll disappear. So there will become a balance of of value versus cost of like any other supply demand in economics. But exactly what that looks like in 2030, who knows? Let's try and get through 2026 first, and because it changes so fast every week that there's something new. I mean, who saw the OpenClaw thing coming? That just fell out of the sky in felt like a few weeks.
Well, I mean, DeepSeek also, right? DeepSeek V3,
Yeah.
that shook everything up, and nobody saw that come. Well, some people did, but most people didn't, and boom. So it's the same kind of.
There's a lot. By the way, just the I did a math degree a long time ago, and reading about how these language models work and the linear algebra that's in there and so on, they're horrendously inefficient. I mean, the way of we have to expend so much energy and so much complexity with these 2 nanometer chips, and we need 100 million of them to build a thing, and 100,000, whatever. Incredibly inefficient to create a human brain. And DeepSeek's already shown that there are some big shortcuts that can be had. I have a feeling there's a lot more to come. The cost of this could also just collapse, the cost of building these models and training them.
What's your PDoom score, John?
I heard you talking about that, and I actually don't know what the scale is.
It's 0 to 1. It's a probability percentage between 0%, meaning we're all going to ride off into the sunset singing Kumbaya, rainbows, Care Bears, glitter, unicorns, and all that thing. And then 100% is Terminator. So what's your PDoom score?
I'm way more worried about the next pandemic than I'm worried about AI taking over, honestly. I think there are many more ways that humanity can suffer, and unexpected meteor that we didn't see coming from outside the solar system. I mean, there's so many more things that can go wrong rather than AI taking over. Is 0 good or bad? Or 0 to which end? 1 is we're all dead tomorrow.
0 is rainbows and unicorns. 100 is we're all dead tomorrow.
I'm going to go with 0.2. How about that?
Well, on that note, John, this has been a lot of fun.
Yeah, I enjoyed this. This was great. Thank you again.
Yeah, this was good.
The invite.
Well, thank you for joining us, and I'm sure we'll find an excuse to do something like this again here in the near future at some point. Everybody, Jon Rolls, thank you for joining us, and on behalf of my co-host Matt Konwiser, to those that are listening and watching, thank you so much for your time and attention, and we'll catch you on the next edition of AI Diatribe. Thanks, everybody.
Right. Thank you.